Hey everyone, I am really sorry that I can't be there today. My son is super sick and we've been up like all night, so you have to forgive me. I'm a little tired, I don't look great, but I wanted to make sure that you can do this. I'm actually not even sure you can see me, so that works. But we're going to talk for a second about KP versus KC because I don't want you to get terribly behind. And so this video, we're going to talk just briefly about what KP is and then how we can use it to solve problems. So KP, you'll see, is very similar to KC. The only difference is the P is representing pressure instead of concentration. But if we go to set up our equilibrium expression, it's going to be very similar. So I'm still going to use products over reactants, but now this time my KP is going to be equal to, and I'm going to say a pressure value. And I would say as my subscript on my pressure value, whatever the compound is, NaCl. And this one, it happens to be squared. And then I'm going to put on the bottom my reactants, pressure of NO, and this one needs to be squared. Those both are squared because of the coefficients in the problem. And then last but certainly not least, pressure of Cl2 is going to be my last compound. So that would be my equilibrium expression. So then I could use my values. Let's say if I told you that these were the values at equilibrium, then I can use these values here and plug them in to the KP equation to solve for that. So let's do that now. And you guys try it along with me. And I'm going to do this here and you can see what you think. So 1.2 ATM is going to be squared over 5 times 10 to the negative second ATM. Square that. And 3 times 10 to the negative first ATM, not squared. So when we go to solve those problems out, then your KP value, go ahead and multiply, give you a second. Hopefully you'll finish that up shortly. Your KP value is going to be 1,920. In this instance, you do want to put a unit with it because there are so many pressure units. So there could be any values of pressure, and we want to make sure that we associate with them what they actually are. And so my pressure unit on this is going to be ATM. I don't know what that looks like for you guys. I'm curious about that. So these values are going to be considered the equilibrium partial pressures. So one thing I want to make sure you're careful with is that these here, sorry, I just want to make sure that this doesn't look crazy for you. I'm going to erase all this stuff here. So these here are my partial pressures. So don't be stressed about what that word means. Partial pressure just means that you have, each of these are part of a total pressure. So imagine that we had a balloon and inside you're going to have all of these different compounds. And so those all together equal your total pressure. And that's all it's talking about. It's just that this is part and this is part and this is part of the total. So don't let that stress you out. And we're going to keep going and chug along and practice another problem. So I'm going to stop sharing this screen. And I want to find a different screen. Hi, everybody. Sorry. I know. This is not doing what I'm telling it to. Okay, we'll just stop the broadcast here.